watch it later, you
Just in
know,
case, you need it.
just for my personal spank bank, if you will.
Okay. I didn't realize AWS was going into your personal bank, but good.
Yeah. Yeah. Think about all the networks. This
Uh,
is part of the recording now. You can never unrecord this.
no, never, I never will. So this is going to be permanent. I'll just gonna make sure this is on my resume from now on. This
Yeah.
is how much people like my classes. It goes in their personal spank banks. So anyway, moving on. Could you imagine if I did like, because there was a time for a while where it was like, let's make IT sexy again. It
What?
was like, could you imagine if it was like that was actually the focus? That would be hilarious.
Yeah, you should do like the naked news, but it's the naked AWS class.
This is the naked cloud.
Yes.
Okay, so here's what we're gonna do. So this is arguably one of the densest modules, just so you know. Arguably
I'm
one of the
so
densest.
ready.
Okay,
Oh
so we're gonna,
yeah.
this is all about how things stay connected, right? So we're gonna follow our coffee shop model, right? We've got our customers, they're gonna give their orders to a cashier, the cashier is gonna give it to a barista, right? So suppose that the customers try to skip the line, right? Somebody tries to do this.
Fuck those customers.
That's right. Burn those guys to the ground. We don't want that, right?
With the
This,
firewall.
first of all, they're disrupting our process. The barista now is responding to multiple inputs. And as you probably know, context switching is the worst thing you can do to a human being. It's also the worst thing you can do to a processor. So oddly enough, CPUs, computers, and people work the same way. If you start adding too many context switches to them, they start choking because it's too costly, right? So instead, we want to block that off so that, you know, there's a certain flow that is followed and people can't jump the line. What did they say every morning? It took me a while to figure out what they were saying when we were at Orange Theory. They were like, hey, don't jump your rails. I was like, jump your rails? What rails? What are we talking about? I think they mean like, don't jump your feet off the treadmill and put them off
Yeah.
to the side. I'm like, why wouldn't you just stop it? But I guess some people jump. Who knows?
I guess some people do, but it's not us.
Not us jumping the rails. It's probably a Vada person jumping the rails. I'm just saying. Okay. So the first thing to know is that the like largest like unit like of networking inside of AWS is called a virtual private cloud. This is a networking segment, like like almost like an organizational unit that you can create inside your account. So this allows you basically to take one account and you can actually create isolated networks for different purposes. Like maybe if you were hosting like 2 customers worth of stuff, you might have one customer and one VPC, another customer and another VPC, right? So like in this particular case, inside that whole like virtual private cloud, you might have someone who's the public face of your application. In this case, like a public workstation, like the point of order, right? Like when you walk into a coffee shop, you go talk to the cashier to order, you don't lob it over to the barista, right? And then the barista is private. Like even though it's social, you know that you don't walk into Starbucks and just start talking to the barista, right? You talk to the cashier and they take care of things. So a subnet is what those little private segments of a VPC are. And so the way this works with computing is that you've got the VPC, which is inside of your cloud account. And inside the VPC, you create these subnets, either public or private subnets. Now, this isn't much different than what we do at our houses. Like right now, you and I are talking, but we're actually on private subnets. How do we know? Because my computer is not accessible to the internet. So these are private subnets. There's a firewall between the internet and my like computer workstation that's sitting underneath my desk. The reason is if I put this computer out on the internet, it'll get hacked within about 2 minutes. So most people run their stuff on what we call private subnets, which means the internet cannot get directly to the thing. But when you're running a web server, you don't know where your customers are going to be. So you need to put that typically on a public subnet in order for it to get access, or you need to have a proxy out there on the public subnet who will then allow you to get to your web server, which could be on a private subnet. Regardless, somebody has to be on a public subnet in order for it to be public. Does that make sense?
Yes.
So in this particular case, and this is how most of the websites of the world work, when someone goes, let's say to, oh, that is so not with the color I wanted. If someone comes in and they're going to www.amazon.com, it actually hits a device that's actually on this public subnet right here. And then it redirects to, and this looks like, these are obviously databases, but they could actually be the web servers. So you may remember those load balancers we were talking about before. Those are little networking devices that act as proxies. These things right here could actually be load balancers, and they are redirecting to virtual machines that are on the back end. But just so you know, anything that's going to resolve publicly across the internet has to be on a public subnet. If it doesn't, then it's not on the internet and people can't find it. So it's kind of like this dual thing of like, you want to make your website public, but here's the problem. Making it public means it exposes it to scrutiny from the internet, which means it could get hacked and you have to defend it. You have to harden it. You have to do all the stuff. So the typical recommendation is that instead of you starting like a virtual machine or a container or something else and you sticking it on the internet, which means you're now responsible for securing it, instead put one of Amazon's proxies in front of it, stick that on the internet, and then Amazon's responsible for defending it. You're not responsible for defending it. So that's the general recommendation. But the main clue here is just to understand the difference between a public subnet, which can get to the internet, and a private subnet, which cannot get to the internet, has no access.
Yeah, got it.
Yeah. So like we couldn't have this conversation if we didn't, because the way our home networks work, the way this is working is there's actually a device, in this case, it's a cable modem or router that we have inside of our home networks. And what happens is that let's say this was my system right here. It's actually talking to the router or network, and the router is talking to the internet on my behalf. So that's called a NAT gateway. And we automatically have NAT gateways on all of our little home router devices.
Smart.
Yeah. It's been that way for like 20 years. So it's actually, yeah, it's really smart that we do it that way. Okay. So if the VPC, which is right here, has some networking information, and this is like the big piece, the big pie, like think of it like a big old apple pie, like a networking pie. The public any subnet, whether it's public or private, that comes after is always a slice of this pie. Now normally we would get into some math if this was one of the associates level things, but there's numbers associated with this thing that like derives like what a network actually is comprised of. Because as you can imagine, computers don't talk to each other through like addresses. They use what's called IP
addresses. Yeah.
IP addresses. Yeah, exactly. And so a computer on the internet actually has a publicly accessible IP address, but a computer on a private subnet could use any range of what they call RFC 1918. These are private addresses. They usually start with a 10, a 192, or a 172. So we'll get to that later on, but just know for now that the subnets are a slice of the VPC.
Got it.
Yeah, that's the main thing.
And a question. VPC exists all on one accessibility zone or just one region across many accessibility zones?
So a VPC can eat an entire region, but a subnet can only live in one and only one availability zone.
Okay, so each subnet is in an availability zone, but the VPC can be in a region.
Yeah, so VPCs span all the availability zones inside of a region. Subnets can only live in one AZ inside of a region.
Okay, got it.
Yeah, let me give you a visual representation of that just to make sure. Wow, what did I do with that thing? Oh, I didn't open it yet. Let's try this instead. Are you still logged in? Let's see. Oh, no, you're not logged in. Hold on.
I made an IM account for my account.
Good. Yeah, I saw you got the CLI working and everything. That was brilliant. Absolutely brilliant. Huh. Oh, no. I can't get to my MFA. Let's see here. There we go. There we go. So yeah, that's okay because I actually wrote it down. So let's go look at a VPC. So if we're here and so I've got one VPC by default inside of my account. This VPC, by the way, is using a 172 address because when you create a VPC it's like by default, it's like private. You have to like specify a private number. It's either going to be a 10, a 192, or a 172 address. The rest of that, by the way, as far as like what all these numbers mean, is a lot of like binary XOR notation, which we'll get to later on, but not now because that's too deep for where we're at. But inside this VPC, if I click inside of it, it actually has what's called subnets. And so if I click on subnets on the left-hand side, notice there's 3 subnets up here, and they are associated with that VPC that I was just looking at. How do we know? Because it's the only VPC I had, so there's no other VPC in there. Notice that these guys also start with 172, but notice that they have different third numbers, either a 0, a 16, or a 32.
Yeah.
Notice also that they only exist in one availability zone.
Well, they exist in different availability zones, but just one region.
Well, they're in the same region because they're all in US East 2C, but the subnets, one of them is in C, one of them is in A, and one of them is in B.
Yeah.
But you don't see them spanning 2 availability zones. Since availability zones are basically data centers, subnets can only live in a physical location. Regions are not really physical locations.
Each individual subnet is only in one availability.
Only one. Yeah.
Okay,
so you can't run that subnet across 2 availability zones. It can only live in one availability zone. That shows up on the exam quite a few times, actually.
Well, I know that shit.
Yeah.
So I hope it's on the exam. That one I'm gonna get.
We're good. You're gonna get it. Perfect. Just know also that since these subnets are part of that VPC, this VPC that we were just looking at, every VPC, when you create it, automatically has a virtual device called an internet gateway. That internet gateway allows you to connect to the internet. It's a virtual device, which means there's no bandwidth limit. You can't overpower it. You can try, but it actually is hooked into Amazon's backbone, and it's like terabits of speed. It's ridiculous. So just be aware that every time you create a VPC, there's one and only one internet gateway, and you can't really add another. You can't add another one because it's not really a single device. It's actually just a portal to like 1,500 devices. So you don't really mess with it. You don't change it. The only thing you can change is whether or not there is a mapping for the network to whether it knows about the internet gateway. You can't remove the internet gateway. You can just pretend it's not there.
Got it.
By removing any reference to it, but it always stays attached to your VPC.
Even if it's private.
Yeah, if it's private. So here's the interesting thing. If we go back to this previous drawing, a private subnet, and so like pretend this is the internet gateway. A private subnet has no direct access to an internet gateway. It can talk to other subnets, but the public subnet has direct access to the internet gateway. And if the firewalls are opened up, the internet can actually talk to the public subnet.
Yeah, but like you just said that every time you make a VPC or whatever, it has an internet gateway. You're talking about just the big part.
Just the big
part. If you make the private one private, it doesn't connect to the internet gateway.
Yeah, because for every subnet that you create, there's a little map. It's almost like a roadmap that's associated with each subnet. And each of these roadmaps will tell you how to get places. But if your map doesn't have an entry for the internet gateway, this private subnet can't get to the internet.
Yeah, so you would have it talk to the public subnet.
If you wanted to route through the public subnet, so you wanted someone to act as a proxy on your behalf, yes, that's how you do it.
Okay. Yeah. Or you could just have it be private.
Or you just have it be private, honestly, which is fine. So there's ways around that to make it so you can still get to stuff on the internet without the internet getting to you on private subnets. So the internet gateway is an indispensable piece of any VPC and is required obviously for public subnets to function, right?
Mm-hmm.
Now, let's say that you created a private subnet because you don't care about this subnet having any access directly to the internet. What you can do, yeah, fuck the internet. It's a dangerous place, actually. So what you can do is you can actually hook your home net, like your house. Actually, you could hook up your house if you want to, or your corporate office, or your corporate data center. And what you can do is you can actually hook the networking device that you have in your home. Oddly enough, you could actually hook it up so it could talk to your VPC, which then in turn could allow you to talk to your private subnets.
Could you
There's two,
just say that again?
yeah. So you can actually hook up your like networks outside of Amazon. You can actually hook them over the internet to Amazon networks. So instead of like having to run through the public internet, you could actually hook it through what's called a private connection. And it looks like it would be running across the internet, but what it's actually doing is it's actually running through this encrypted tunnel that goes over to the private subnet. So it's not accessible to anybody unless they have access to your little private tunnel.
Which
The
is
thing-
just an encrypted part of the public
Yes,
internet.
exactly. It's an encrypted part of the public internet. So unless they are able to break your encryption, which, you know, probably will happen in about 20 years when quantum computing is really common. But until they can do that for the time being, it's actually remarkably secure. And what will happen is that all your data will actually reside inside this little private tunnel across the internet. But it'll all be encrypted, which means it's all scrambled mathematically. So no one can decrypt it unless they have the keys. And as long as your keys are secure, which most people are really good about that, no one can get access to the data inside your private tunnel. This is called, by the way, a VPN.
Yeah.
And VPN is available to far more than just through AWS, but just know that AWS has native tooling for this.
Yeah. I mean, you use it for everything. Like you use it for work.
Yeah, exactly. That's exactly right. Most enterprises, if you want to get access to corporate resources, you have to run a VPN that they give you the access to.
Yeah, exactly.
So in order for enable VPN, you do have to run what's called a virtual private gateway. So another option, by the way, if you don't want to run a connection over the internet because you like want it to be more consistent, because remember, you know, like for example, at 10 o'clock at night when everybody's watching Netflix, the internet actually does choke out a little bit because about a third of the traffic is, you know, video traffic. And if you're like, oh, that's not consistent enough for me because things might slow down a little bit for you, what you can do is you can actually do a physical wire. So you can actually run a physical wire to one of Amazon's partners, and then they'll hook your wire up to your VPC, and that will talk to your subnets. So from
Cool.
here, yeah, so from here you can get to the rest of the stuff. So Amazon doesn't let you hook
That's a
directly
lot
into
of
their data
fun.
centers, but they have partners you can hook into.
Cool.
Yeah. That way they can supposedly hide where they're at. Although if you go into Google Maps and type on Amazon data center, apparently people do know actually where some of them are. So it's kind of funny. So two ways to get connected to private networks or private and public networks is you can use VPN, virtual private networking, or you can use this direct connect. This direct connect cable, by the way, can be 1 gigabit, 10 gigabit, or 100 gigabit speeds. So it can be really fast. To give you a sample, most cable connections run at like 200 megabits, which is 1/5 of what a gigabit connection would be. Okay, so you've got that physical cable you can go for. By the way, this isn't inherently more secure. You actually have to add encryption to the wire, but it is more consistent. If they give you a gigabit of bandwidth, you're going to have a gigabit. If you try to pull a gigabit of bandwidth off of VPN, I think you're capped at like 20 megabits or something slower. So I can't remember the exact limit. So those are the two connectivity options: a virtual private gateway using VPN or direct connect itself. So any questions about that?
No.
Good. All right, so then let's put these together here. So if we want to isolate databases containing customers like personal information because it's more sensitive, what kind of networking object?
Private subnet.
Okay, good. You got it. Good. If you want to create a VPN connection between VPC and internal corporate network, what would you use for that?
Virtual private gateway.
Good. If you want to support a public customer facing website.
Public subnet.
Good. And if you want to establish a dedicated connection between an on-premise data center and the VPC.
AWS Direct Connect.
Really easy, right? Because it's the last
Yeah.
one, which you got it anyway.
I know. I thought about joking about it, but I knew that would just waste time.
Got time. All right. So then that's just like the fundamentals of the networking. Most of the time, by the way, when you're in like AWS, you either set it up programmatically, or if you want to create a VPC, they actually have a VPC wizard if you decide to do it through the interface. Most people are going to do it programmatically. They're going to use Terraform or the command line to set it up, or CloudFormation. They're not going to use the console. But if you're just messing around, you can set up a single public subnet, public and privates. You can add hardware VPN access, or a private subnet with only. So it'll actually walk you through all the connectivity options.
Wow, that's freaking hilarious.
Yeah. So like if you do this one, by the way, it'll ask you a bunch of questions about numbers and what you want to use, and where do you want, what availability zones do you want to use? And you know, do you want to add any kind of service endpoints? Oh, look, there's DynamoDB. So the gateway and interface endpoints, they'll allow you to set those up.
Cool.
Wow. Are those the only two here? What happened to the others?
Maybe they don't do whatever this.
Oh, they only
ridiculous
do,
thing.
they only do the interface and the gateway endpoints. That's interesting. Huh. Hold on. I have one little curiosity here. That must be under. That's weird. Huh. Now I'm like super curious as to why they're doing that, but whatever. That's not relevant for us. So anyway, it's just that simple to create a VPC. Hold on.
Good. I want it to appear hard and be simple. That's my favorite way to play.
Okay, yeah, so there's the gateway endpoint, and then S3 must be somewhere in here. So there's DynamoDB, and oh, there's a bunch of pages. Hold on. 1 second.
There's 125 pages actually.
All right, so there's the other one. Okay. Oh, that's so weird. Huh. Okay. Learn something new. Okay. So moving past that, let's talk about then firewalls. So, you know, there's like this chain of devices that is required, that has to be traversed to go from like a virtual machine all the way out to the internet, and from the internet all the way in. There's like, you know, 5 devices that have to be traversed. The VPC and the subnet are kind of 2 of those objects that have to be traversed, but there's actually 2 other objects that are in the middle of that are required in order, and you have to kind of get past them, because think of them as like walls. They're castle walls. So in this particular case, let's say a client is trying to send some information to a web server. And so they come in here and they're trying to get like past, you know, the internet gateway into the VPC, into the subnet, and they're trying to get to the instance. Well, in order for them to do that, they've got to first go past the first, and it's not actually the first, but the second firewall that you run into. And so this firewall is called a security group. Oh, sorry. You ever hit the wrong buttons?
Never. I'm perfect.
Ever. That's true. I can see that. All right, so here it is that they passed this security group, and the security group is a stateful firewall. The thing that's weird about security groups is that they are actually attached to anything that has a network card. So a virtual machine obviously has a network card,
Yeah.
because it's a virtual machine. It has to be able to get to the internet, right? So security groups are stateful, by the way, and so they're like, they're firewalls that basically are necessary for you to get, like, you got to get through them, right, in order for it to function. Now, what's interesting is as this packet comes in, it goes across the internet gateway, and then it has to get past a firewall that's actually around the entire subnet. So there's a firewall around the subnet, and it's, you know, yeah,
That's stateless.
that's right. It's stateless. Here we go. This is bigger. So there's one here, there's one here. So if we were to kind of like look at this as in terms of traversal, what has to happen is that a packet has to resolve, first of all, across the internet gateway through the VPC. Then it has to get past the first firewall, which is the NACL, which, by the way, by default, NACLs are wide open. Most of the
I
time,
was gonna say, what's the even point of the first one if it's a public subnet or like on a web server? Wouldn't it just be like, come on in?
typically. But what would happen is that, let's say there were a bunch of people from Nigeria and Malaysia who were like messing with your web server. You could actually put blocks in here to block it, so it wouldn't allow those IP addresses to come in.
Yeah,
You can't do that with security groups. You can only do that with NACLs.
that's
Okay.
good to know.
So someone comes in, traverses the VPC internet gateway. They get through the firewall. Then what has to happen is they have to get through the security group and then they can hit the instance. The reverse is true. Through the security group, through the NACL, across the internet gateway, all the way out. So the reverse is true as well. Does that make sense?
Yes.
Cool. The main problems that arise when it comes to permissions are all related to this part and this part. Typically,
Yeah.
it's this part that's the problem.
Yeah.
The only
I
other
can,
thing, sorry, go ahead.
I can see that. Sorry. I was just
No,
reading.
it's all good. The only other thing that's an issue is those maps. They're also called routing tables. They can exist at the VPC level and they can exist at the subnet level. Those are sometimes the other problem, is that if those subnets are not set up correctly, then you have to take a look at that. They're called routing tables. And if you're looking at the interface,
So they're like lists of IP addresses, right? Kind of.
yeah, let me show you one so you can get an idea. So these are route tables. Here's a route table. So the route tables have routes in them and they look like this down here. So what this does is this says, hey, if you're just looking for anything on the local network, just go local.
Yeah.
If it's not on the local network, which is what this means, then send it to the internet gateway.
Yeah.
So
Okay.
there's only
Got it.
2 entries in this, right? And so every subnet inherits this route table in that particular configuration, but you can create a custom route table for every subnet if you want to. But in this
Yeah.
particular case, they are inheriting from the VPC.
Got it. And this is separate from the security group or the NACL.
That's exactly right. If we look at the network ACL, if we look at the rules for this one, right now it allows all traffic through, right?
Yeah.
By default, it's allowing all traffic from any source.
Yeah.
Yeah, the security groups, there's a default security group. Let's take a look at it. So this security group is allowing all traffic by default into everything as long as it comes from, well, what is that actually? Hold on. Oh, if it's a member of the default security group, it's allowed to do to allow to talk to anybody from who is inside the same security group.
Security group. And
If you're
that's like an instance can be inside of a security group, and you can make other instances also part of that security group.
You can add as many instances to a security group as you want.
And so this is just saying anything that's already inside the security group can talk to me.
Right. Anybody who's in the security group, they can all talk to each other.
And but it's this one's also saying that like nobody else fucking can because fuck them.
Yeah, because it's basically saying the only source, it has to be somebody who's in the security group. In other words, it kind of constrains it to just machines that are inside the security group. So like the internet couldn't get to these boxes
Yeah.
because
Unless
the
you
source,
change the permission, like you said, you could add in like and your IP address, so you could right? Yeah. Okay. Yeah,
Yeah.
that's what I thought.
yeah, so I could add in my IP address. It's just what this is right here. But this custom rule apparently, this is a default security group which comes with all AWS accounts by default. You can't edit it, so I'd have to create a new one.
Yeah, okay, got it.
Yeah, I was creating a new security group and give it a name and set the VPC and add rules. You can set, so security groups can only allow access because by default they deny everything. So you can only create what's called inbound or outbound allow rules in a security group. With NACLs, you have a lot more flexibility at the cost of more complication.
Yeah. And it goes, NACLs have allow and deny, right? So like
Yes.
it just reads down the list, doesn't it? And as soon as something fits into a category, it just does whichever one.
Exactly right. So like in this particular one, if we were to edit the inbound rules, you'll notice that if I added a new rule and I made it, rule 1, and I said all traffic and I was going to set it to deny, and I was
It
to
would
save
never
those.
allow anything because it comes first.
Exactly. In other words, precedence makes a huge difference with NACLs. With security groups, there is no precedence. If you're allowing it and it matches the rule, then it just allows it to happen. So like by default, you're right. I just changed that whole thing to where basically it's going to deny traffic because that's rule 1, right?
Yeah.
But if I removed it, then now we're back to all traffic being the first pattern match. Because remember, this thing right here basically says all IP addresses. So anything that comes and talks to the subnet is going to be able to get in.
Great. Mm,
Oh, I didn't know they had a sort by rule number. That's a new feature. And notice that by default, the deny that's at the end of this cannot be removed.
yeah.
So by default, if the traffic comes in and it doesn't match any of the allows, it's going to deny it.
Yeah.
So
And they thought we were so stupid we would get rid of that, so they just made it so we couldn't.
yeah, well, just so you can't like there's no accents, you just can't. Because Amazon, can you imagine if people accidentally did that, then it would open up their subnets to a bunch of traffic they don't
Oh
want.
my God, it would fuck with people.
And you wouldn't know until you got hacked. So in most cases. So that's network traffic inside of a VPC, and these are all the various objects that it traverses. You can, by the way, add objects outside of the VPC. So like you can add web application firewalls, you can add CloudFront can sit out here. You can add additional stuff, but it's all outside the VPC. It's not inside the VPC. The only other thing that you can add that you saw me messing with is that you can add what's called endpoints. Endpoints allow private subnets to get to public like services like S3 or DynamoDB. So
Oh, okay.
that's
Got
why I
it.
was looking at them
So it's like a way for a machine to access the public service.
without having to go public.
Yeah. Okay,
Yeah.
got it.
Yeah, it's a
And
little
that's
trick.
just an Amazon service.
It is. It's an Amazon service. It's something private to them.
Okay.
All right. So network access control lists. And we talked about those already. They allow all traffic inbound. They allow all inbound and outbound by default. Oops. You can deny as you see fit. So we think we talked about that. Stateless packet filtering. Yeah, so the NACLs are called stateless because it requires 2 rules, one to receive and one to send, which is a little weird because Caroline, if I was like, hey, Caroline, how you doing? And you had a rule that allowed me to talk to you, it would be assumed that you would have a rule to talk back to me.
I
But
didn't
that's
know.
what but it doesn't. So security groups do. Security groups track conversations. So if a security group sees you initiate a conversation with something and you have permissions to do so, it assumes that you want the thing to respond.
Yeah.
NACLs don't do that. NACLs, it's like, I have to seek consent on both sides. Hey, is it okay if I talk to you? And it's like, yes. And it's like, and you'd be like, is it okay if I talk to you? And I'd be like, yes. And then it's like NACLs assume work that way around consent. Whereas security groups are like, it's okay if you talk to me, Michael. And my assumption is if I talk to you, you would assume that it's okay for you to talk to me. So that's the difference between stateless and stateful. So again, just remember 2 rules. Now, security groups are the ones that you only need 1 rule. And by default, the security group is where actually security lies when you start EC2 instances, because the NACL is wide open. So it just allows the traffic to go through. But the security group is going to be like, no, you can't talk to anybody unless you allow it. And so by default, it's going to deny all traffic. Now, remember, if you decide that you're going to stick a network interface inside of a subnet for whatever reason, because you want to use it for like a Lambda function or a container, but particularly if you start EC2 instances, every time you add a network interface, a network card inside Amazon, it has a firewall around it. So you can enable it, disable it, do whatever you want with it. It's just a security feature for them. They just want you to make sure that you have the option to block things if you put a network card inside of AWS. That's stateful packet filtering. Oh, yeah. I think we already kind of covered this inadvertently. But packets go here, they go into the VPC, they traverse the network control list, they go across the security group, and then they hit the instance. So no surprises there. Questions about that? I'm so glad that Neil got you prepped ahead of time. Caroline, are you still there?
There's like a time limit on the state.
Let's see. Caroline, can you
No.
hear me?
There's like a time limit. Yeah, I do have a question, but I don't think you can hear me. Hear me?
I
You
hear you
hear
breaking
me?
up. Let me
Can
just
you
check
hear
and see
me?
if I'm choking out.
I think, yeah,
Oh
can
no,
you hear me? I can hear you.
I'm definitely not choking out. So I'm at 311 megs per second. So I just
How
turned
about
off my,
now? No, how now? How about
okay, I can hear you now. But you might want to turn your video off for a second. There you are.
back? Sorry, I don't know what the fuck that was.
Yeah,
Okay, so you can hear me now, though.
I can hear you now. So
Um,
did you?
question. So stateful security group, there's like a time limit on that, right? Like if somebody's like I talk to somebody, I am expecting them to talk back to me in a reasonable amount of time.
Yes. If you open up a connection using like a flavor called TCP, there's an expected like time that you respond, and it's called the connection await period. It's usually honestly only a second or two. They expect that you're going to get back
Yeah,
to
I
them
was
within
thinking,
milliseconds. Yeah.
yeah, that's what I thought. So like after that, they would be denied again.
In other
Presume.
words, you'd have to reinitiate if they're not going to respond. If I was like, "Hey, Caroline," and you didn't respond for like 60 seconds, it would drop the connection, and I'd have to reinitiate.
That's what I thought. I was just curious about that.
Yeah, so sometimes attackers, what they'll do is they'll initiate a bunch of hey, hey, whatever, and they'll open a bunch of connections, but they won't actually respond to the connection once they establish it with the person. And so what they're trying to do is sort of trying to tie up the networking stack on the service in question, so it'll crash, basically.
Yeah. Assholes, unless they're doing it for good.
But you never really know. So what are the differences between NACLs and security groups? So I think
Net
you know.
oh, NACLs exist at the VPN level, and they are stateless, which means you got to have consent both ways. If you send somebody data, they also have to have permission to send you data. And then security groups are stateful, which means that if you send someone data, they can send it back in a certain period of time, and they're at the instance level. So they're even smaller than the subgroup level.
Yeah, so just one small like specific correction on language, because that was like 99% flawless, right? Is that NACLs exist at the subnet level, not the VPC level.
Thank you. I
Yeah,
needed that correction.
yeah, they are boundaries around the subnet. So if you got 10 subnets, you've got 10 NACLs.
Got 10 NACLs. Okay.
Yeah, but
Got
other than
it.
that, perfect. And instances is actually technically correct. For your edification, just know that security groups exist around everything that has a network card. But
So
in the test, it's referred to as instances.
so does that mean that like there's another one around the subnet, or what does that mean? What's the clarification that you're offering?
What I'm saying is that people think of instances as the only thing as having a network card. They're not the only things that have a network card. There are other things in AWS that have network cards that actually could sit on a subnet,
Oh, okay. And
like
what's your name one?
containers. You can actually attach a network card to a container.
Okay. And then it would have anything you put a network card on, gets a security group.
And just to be clear, you don't have to run containers with a network card attached. They have their own internal networking, but if you do decide to do that, you're going to get a firewall with it. Lambda serverless is the same thing. You can run Lambdas most of the time without attaching a NIC to it, but if you do attach a NIC, a network interface card to it, it's going to get a firewall. So
And what does a network interface card do exactly? Is that like the internet gateway?
no, what it does is it allows whatever it is you're trying to execute in a specific network location. So I'll give you an example. If you had two private subnets and they were both in two availability zones and they had databases in them, and you had a Lambda function, which normally would run over in Lambda, like at the regional level, and you wanted that function to run inside your subnets for both because your databases were there because they were private, you could actually literally take that Lambda, attach a network interface card to it, and put it inside your subnets.
Okay, got it. So you would do that if you were going to use a service that would normally be done in cloud
Mhm.
on your subnet
Exactly. So if you wanted it to run inside your subnets, that's how you do it.
rather than a service out. Okay,
Yeah.
got it.
because remember how the services operate either at an AZ level, a regional level, or a global level. Lambda is a regional service, but sometimes you want it to be closer to where your data is, and so when you attach a NIC to it, it actually runs now inside of an availability zone. That's the only reason to attach a network card to a service, is to get it to go from regional to AZ.
Got it.
Yeah. Okay, well, sounds like you've got that concept down. Stateless and stateful, you described that pretty well. Subnets and instances. Yeah, you actually said that flawlessly, so good job. Oh, good. We're doing great on time too. Okay, so let's talk about the stuff that happens outside of the VPC. So that was all core networking stuff. So now we're going to talk about stuff that happens outside. There's really two services that are important here. One you already know. It's called DNS. And the reason everybody knows DNS is when we type in www.amazon.com, that's the DNS service. It translates human readable names into computer readable IP addresses.
Yeah.
Yeah. So what happens is that most of us, when we're hooked up to the internet, we actually use our internet provider's DNS resolver. So like I'm on Xfinity, obviously Comcast. And so Comcast or Xfinity has a resolver just sitting right outside, not physically, but just outside of my network. And so when I go to resolve www.amazon.com, I actually go and talk to Xfinity's resolver. And that resolver actually goes all the way up to the root directory of the entire internet and says, hey, who has the .com domain name? And it points us to another server, and the .com server says, oh, you're looking for Amazon? Amazon's DNS servers are over here. And then when I get to Amazon, I then go to Amazon servers and I say, hey, where is www? And they're like, oh, it's over here. All that happens in milliseconds, like quick. First you go to .com, then you go to amazon.com, and then you go to www.amazon.com, and it happens really fast. And so that orange step is the step of me talking to amazon.com, or the resolver, sorry, talking to amazon.com servers and saying, hey, where is www.amazon.com? And it returns, by the way, an IP address, which I don't actually see. And then that gets loaded up into the browser. So all of that happens like super fast.
So
And by
could
the way,
I actually, if I knew the IP address, could I just type that in? Cool.
let's see if it works.
It says
Oh,
fuck you.
it's not going to let me do it because there's a security thing, but hold on, let's see if it lets me do it. No, it's not going to do it. Let's try this instead. This is a CloudFront distribution. So let's see if that loads. Look at that.
Look at that.
Notice it doesn't say www.amazon.com up there.
No, it says bunch of gobbledygook.
Good, like CloudFront, right? But if I go to amazon.com, it should show the same page. Right? Boop.
Cool.
Yeah, the reason sometimes the IP addresses don't work in Amazon because they're not actually servers. It's actually a redirect. And if you don't submit a domain name on the redirect, it won't let you, it doesn't know where to go. So sometimes the IP addresses don't work. But if it was a single web server, it would work fine.
Yeah, if it was like a simpler web page.
But Amazon probably has 2,000 web servers on the back of their stuff, so it doesn't work that way. Okay, so DNS, by the way, only Amazon service that has 100% SLA, 100% service level agreement. Because if it goes down, a large portion of the internet goes down. There are 11 tier 1 providers in the world that provide the backbone for the entire internet across the entire world. If any one of them goes down, 1/10 of the internet is down at any given time. So DNS is the one service that unifies them all. And it's the one service that everybody makes sure stays up 100%, because like I said, it goes down, everything goes down. Even if it's not actually down, like the servers aren't actually down, you just can't find them. So that's what DNS is it's the roadmap. So Route 53 is the name of Amazon's DNS service. And the reason it's called Route 53 is that DNS has a service runs on what's called a port, and it's port 53. So instead of calling it Route 66, like the famous road out in the west side, right? They call it Route 53 because 53 is the port. because that's, I guess, a little geek humor. Now, Route 53 is the DNS resolution service, and it works in conjunction with another product called CloudFront, which you just actually saw with Amazon.com. You saw CloudFront in the name. CloudFront is that one where the servers can be in Russia, and your home webpage could be in Brazil, and it would actually do caching and pick it up from the user and all the other stuff. So CloudFront is the one that actually allows you to put complete copies of your website all over the entire world. And the way that works is that CloudFront is actually pointing to a single, what they call origin or location. Think of it like the home base, and it'll pull copies of whatever's in the home base, and it will put those copies all over the world. Now, those copies are only as fresh as you tell it that they're fresh. So for example, if your web page updates every 24 hours, you might actually have what's called a time to live or a TTL on CloudFront that says, hey, you can cache this for 24 hours, but at midnight on every day, it's going to expire. So don't keep it past midnight every day. So you can actually tell CloudFront how long you want to keep cached copies of your images or videos or website or whatever it is you're pushing across the entire world. Just know that this really only works for static content. So if it's something that gets dynamically generated when a user visits a web page, it's not really going to work that great. It can, but it's not awesome.
Something like that would be like what? Like a shop? Would that be dynamic enough that it couldn't be on CloudFront? Because like their cart would have to update and stuff.
Well, like the cart portion maybe couldn't be, because like the cart portion is dynamic, right? But most of like what we're looking at here, these are just static images, right? For the most part. So all of this is a great candidate to be on CloudFront. But if there was a dynamic recommendation, like if I was on this part, because it's so custom to me, like this is so custom to me, the images and stuff could all be custom, but this whole presentation and the code that's putting it together probably wouldn't be a good candidate. So probably only about 50 to 60% of this website is actually cacheable. It could be more. But the way it's put together, that would all be stuff I'd have to pull directly from the origin. So if I was over in Japan, it might take a little longer to put this together if they didn't have web servers in Japan.
Yeah, okay, got it. So you mean in Africa?
Exactly. Yeah.
Well,
exactly.
I don't even think they have ability to get Amazon deliveries in Africa.
Yeah. It seems like they might in Cape Town. Who knows? In South Africa, right? And let's see. That's it. So those are the two services. So CloudFront is the content distribution network. It does caching from a single point of origin all over the world. And then Route 53 is the DNS service. So you use that to resolve domain names. By the way, you can buy domain names off of Route 53 as well.
Oh, cool. I'm wondering if like, so you know how normal internet traffic goes through port 80? Is this
Right.
port 53 like just an alternative to that? Or what does this mean?
Yeah, that's a great question. So there's a the IATF basically has a list of what's known as well-known ports that are used for different applications. So port 80 is used for HTTP, so for web traffic. Port 443 is used for HTTP that's secure.
Yeah.
And so there's a bunch of well-known port numbers across the internet that most of us have memorized if you've been doing it for years and years and years. But honestly, most people aren't doing that now because most of the stuff is either 80 or 443 traffic. But like DNS, as you can see here, it's port 53.
53.
Yeah.
So not all services who are doing DNS are doing it on port 53.
Yes.
Okay,
And
that was
yeah. Yeah.
Thank you.
Yeah. So I gotta tell you, this probably is less important now than it was like 10, 15, 20 years ago. These are still like the well-known ports for most stuff. But when it gets to like custom applications and stuff, man, they could be using any port number. You don't even really know nowadays. But the one thing to remember is that HTTP, like the thing you just said about 80 and 443, those are really important because they stay consistent.
Yeah.
Yeah.
Okay, cool.
All right, so let's do a little knowledge check.
I'm ready.
What can you use to establish a private dedicated connection between a company's data center and AWS? Physically.
AWS Direct Connect.
Oh yeah. Good. Okay, what statement describes security groups?
Mm, 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 mm. B.
They're stateful and they deny all inbound traffic by default.
Yes.
Looks good. Excellent. Which component is used to connect a VPC to the internet?
Well, it's A.
Yes, because the other ones don't even have anything to do with that, really.
Like, what? The good thing is multiple choice. Goodness.
Yeah. Public subnet requires an internet gateway to be public, and edge location is outside of a VPC, so it doesn't even use internet. And the security group's firewall, so right. Okay, which service is used to manage the DNS records for domain names? Which
Amazon
AWS
Route
is?
53.
Oosh, got it. Good. Okay. What statement describes DNS resolution?
D.
That's right, D. The simple act of translating like Amazon.com to an IP address. Good. Well, that's the whole module 4 right there, right? That's the whole thing. So you just learned about core networking, edge networking, all of its like kind of basic components. Obviously, there's deeper to go, but for the cloud practitioner exam, that's all you really need to understand. So
That's awesome. Thanks for going over that with me.
yeah,
That was really great.
so the next thing we're going to cover, just to be prepared for next time, is we're going to talk about AWS storage. And I think after that, we talk about the database services. So storage is pretty straightforward. But yeah, that's what we're going to cover next.
Awesome. Storage and database.
Storage and databases. Yeah. Cool. All right. So questions, comments, anything you need?
No, just really awesome. If there's anything you think I should do in the labs or anything, let me know.
Well, let's talk about that because I was going to show you this. Dun, 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 dun. Oh, there's our
Who it is.
there's our person.
There's Divya.
Divya. Hello,
Divya.
Miss Divya.
Divya.
Hello.
Hello.
Can you hear me now?
Yeah.
Yes.
This looks fun. I'm gonna let y'all continue. Bye.
No. Stay here. Stay here. We're
Hey, we're
almost
almost
done.
done.
Yeah, don't go.
Okay.
Don't go. All right. So the thing I was going to suggest to you just before we stopped was that oh, that's tricky. Quick Labs should be a VPC thing out here. So introduction to virtual private cloud. That's probably something you want to kick the tires on. That'll cost you $1 to do, just so you know.
Well, I paid them $8. I was just like making an investment, so they can
Yeah.
have those $8.
So I would probably do the introduction to VPC, and that's probably the only one that you need to do for networking. They do have advanced ones on CloudFront, but honestly, those are more advanced labs. Oh, actually, this will be a good one. This is introduction to CloudFront for free. So this is actually a good one to do. So CloudFront and VPCs, I would probably do the labs on those. They're both introductory.
I'm gonna write that down. Okay.
And if you need any technical support with Kubernetes, that's when you talk to Divya.
That's right. I'm that specialist.
Okay, I don't believe that.
No, she's my go-to person. She knows Kubernetes inside and out.
Mm-hmm.
Okay, well, I'm gonna come to you, Divya.
That's
So you
right.
can train me in Kubernetes so I can make bunches of money.
Yeah,
Yay.
if we put Kubernetes on your resume, it's over for you, Caroline. You'll never.
Bunches of money will be thrown at me.
Yeah, it's horrible.
And
You'll
then
never.
I will throw it at you guys. And we'll go to Bali
Yay.
together and then Sydney.
I'm game. I'm all game.
Okay, I'll leave you two alone.
All right, thanks, Caroline.
Oh, except Divya, did you eat any soup today?
I just had a little bit of what Jaya made, but we can have some soup.
I was thinking about having some soup before I do your massage. Do you care which one? You think that chicken one is still good?
I would smell it. If it is, cook it. If it's not,
That's the only soup, right?
well, there's soup, but it's in the freezer.
Got it. Well, that's good. I'm happy we're having this conversation that includes Michael. I feel like he really wanted to hear all about the soup.
I do.
So
I want to know
now,
about the soup.
so now that we've
Soup
done
is
that,
important.
I'm gonna leave you guys alone now.
What time are we still doing a massage?
Yeah, at 5:30, if that still works for you. If not, then we'll just do it when does it work for you?
No, I think that works.
That works for me.
Okay, great. Bye, guys.
Oh yeah.
Bye. If you make something, I want some.
Okay, I'm gonna go smell it. I'm not sure. It's on like the borderline, I'm
I'm
sure.
not sure either. Okay.
Okay. Am I allowed downstairs? I'm not allowed downstairs. Okay.
I haven't gotten my test either. I just finished working.
Yeah. Okay. Bye.
Bye.
They just took a home test. I called Carol Sue and asked. I'm
Do
just
you have
gonna-
a home test?
I have one home test.
Okay.
But
Good.
I mean,
Take it.
okay.
Okay. Bye.
Bye. Okay, how you feeling?
Good. How are you?
No. You can't be feeling good because I feel like fucking hot trash.
I'm tired.
I am so fucking tired. I can barely stand myself. So you've got to be tired too.
Caroline.
now I'm bothering you in here.
Now she's here.
Sweet.
Now she's leaving. How's your session?
Good. She's fun. She's fun to deal with. She's so smart. She's just
You
like,
can stop recording.
oh yeah, probably should stop recording.